It will be, I'll put a link to it on Google Classroom, but it'll be through YouTube. Okay, so let's go ahead. We're looking at 7.1 today. Shouldn't take us a long time. There's not a lot of work involved with 7.1. It's just kind of definition stuff, kind of like we talked about on the warm-ups. So a monomial is a single, remove this. When I say a monomial, it's just a single term. Okay? So it's just one single term. So what I mean by that, we kind of talked about the math definition, is here are some monomials. 2x, y divided by 2, a term cannot be separated by a plus or minus. And we'll look at some examples in a second. Okay? So if I'm adding or subtracting, wherever I'm adding or subtracting is where the terms split up. So wherever I have a plus is where, or a minus is where my terms are going to be split. So monomial is just a single term. There's not going to be any adding or subtracting. And then a constant is just a number, like we talked about. Do not make this harder than it is. I know these are kind of fancy words. Do not overthink this. A constant is just a number. There's no variable with it. No variable. Okay? So example 1, I want to determine whether each expression is a monomial. Write yes or no. Explain your reasoning. Okay? There's not a lot of work involved with this. You're just kind of looking at it. Okay? So a monomial has one term. And a term is separated by a plus or minus. So if I look at example A, you're going to be doing the same stuff in the homework. If I look at example A, I want to know whether it's a monomial. Mono, and any Latin people in here? Oh yeah, maybe. Okay. That's prefix. So mono means one. Okay. So one term. So as I look at example A, how many terms do I have here? A term is separated by plus or minus. So how many terms do I have? Here's one. There's one term. There's two terms. So I have two terms in there. So a term is separated by a plus or minus. So negative x is one term. 5 is my second term. So I have two terms. So is this a monomial? No, because there's two terms. A monomial can only have one term. So there's two terms. So no, it is not a monomial. Not monomial. Now we'll do this later, but what is this going to be? If it has two terms, let's take a guess. What prefix means two? Binomial. So this is a binomial. Two terms. Binomial. Okay. So a term is separated by plus or minus. So that's two terms. Any questions so far? Okay, let's look at B. If I look at B, I want to ask myself, is this one term or is it more than one term? How do I tell whether there's more than one term? It has to be separated by what? Plus or minus. Is there any plus or minus here? Am I adding or subtracting anything? No. So this is only one big term. So if it's, even though I have A, B, C, D, it doesn't matter. A term is separated by plus or minus. So if they're all multiplied, that is one term. So this is a monomial. So yes. Okay, let's look at C. If I look at C, I want to know how many terms I have. So the terms are separated by plus or minus. So if I look at C, do I see any plus or minus? No. So I'm thinking, okay, this might be a monomial, but it needs to be separated by, a monomial cannot have division in it. So how can I rewrite this to only have multiplication? Instead of dividing by 2, how can I rewrite this? Not multiply by 2, multiply by, or a what? Multiplying by 0.5 is the same as multiplying by what? Half. So I can rewrite it like this. Multiply by a half. So yes, this is a monomial because there's only one term. So sometimes if you're dividing by a constant, if you write it as multiplying by a half, you can see it as just basically multiplication. Now be careful. When I look at D, I still see multiplication, so I'm thinking, okay, if I look at C, it's going to be yes, but what's the difference between the division in C and the division in D? What, say that again? Okay, a little more specific, you're on the right track. For part C, I'm dividing by a what? A number, which, let's use fancy words because we can, because we're cool like that. I'm dividing by a number, which just a number is what? Constant. So for part C, I'm dividing by a constant. In part D, am I dividing by a constant? In part D, I'm dividing by what? Variable. So it says no. It is only a monomial if you are dividing by a constant. If I'm dividing by 2 in part C, if I'm dividing by a variable, it is not a monomial. Just be careful with that. There's some on the homework like that. Okay, any questions so far? Not a ton of work. Just got to remember what things mean. Okay? So let's look at product of the powers. All we're worrying about is multiplying. Product means multiplication. Don't make this harder than it is. Product means multiplication. A power means what? What's a power? You know what a power is. Power means what? I have what somewhere. If I have something to the 5th power, what does that mean? Times it by itself, which means what? A power means I have a what? You're overthinking this. If I have something to the 5th power, what does that mean? What does it mean if I have something to the 5th power? I have a what of 5? No? If I have something to the 5th power, to the 2nd power, to the 3rd power, it means I have a what? Which means, well, that little number above it is a what? You're good. You have the definition. What's that little number above it, to the right of it? Exponent. So product means multiplying, power means exponent. So I'm multiplying exponents. So if I have something like this, x to the 2nd times x to the 5th, I am multiplying exponents. Don't make this harder than it is. I know this is kind of weird, but the product means multiplying, the power means I have exponents. I am multiplying exponents. When I am multiplying exponents, let me kind of write it up there, multiplying exponents with they have to have the same base. When I am multiplying my exponents with the same base, what's the base? If I look at x squared and x to the 5th, what would be my base? X. So they both have to have the same base. These have the same base of x. I add the exponents. This is all you do. We're adding numbers together. Do not make this harder than it is. I get this is new stuff to you. I get you struggle with math. But we're adding numbers. That is all we're doing. So if I'm multiplying exponents with the same base, you simply add the exponents. That's all you do. So if I look at this one, x squared times x to the 5th. I'm multiplying. These both have a base of what? X. I do what with my exponents? Exponents. When multiplying exponents with the same base, you add your exponents. So this is going to be x to the 7th. That's it. So if I have the same base and I'm multiplying, you add your exponents. X to the 7th. Okay. Any questions so far? Okay, let's look at a couple of these. Simplify. Let's look at the word simplify. Let's make a note down here on the side. Okay? You're going to see the word simplify a lot in the next couple days. Let me give you kind of a checklist of what simplify means. Okay? Three things you need to check for. A single number or reduced fraction. And let me be a little more specific. A single whole number. Okay, so we need a single number. A single whole number. Okay? So we're looking for a single whole number. That's the first thing we want to look for. The second thing is we need no repeating variables. I know this is kind of confusing right now because I'm using big words. We're going to come back to this as I simplify things. It'll make more sense. So I need to have a single whole number or a reduced fraction. I cannot have any repeating variables. So I can't have x in there more than once. I can't have y in there more than once. I need to reduce them. And no negative exponents, which we're not going to really deal with negative exponents much today. We'll deal with them tomorrow. But just so we have it down. This is what simplifying means. These are kind of the 3 steps to make sure it's simplified. We can't have more than one whole number in there. We can't have any repeating variables, so I can't have x's in there more than once. And I can't have any negative exponents, which we don't really have to deal with the third one today, but that's okay. So let's look at simplifying the first one. First thing I notice is, what am I doing here? If I have a parenthesis next to a parenthesis, I'm doing what? Multiplying. Okay? So I look at this and I'm multiplying. First thing, whole numbers. We need a single whole number here. Do not make this harder than it is. I have a big 3 and I have a big 7. So what is 3 times 7? 21. The whole numbers you treat like normal. So 3 times 7 is 21. They're not exponents. So you don't do anything special with them. I'm multiplying, so you just multiply your whole numbers. 3 times 7 is 21. Now, that was the first one. I have it down to a single number, single whole number, 21. We're good with the first step. The second step is I cannot have any repeating variables. So what variable do I have that shows up twice? Y. So I need to get it down to 1y. So if I am multiplying my y's, they have the same base of y. What do I do with my exponents? So that's going to be y to the 9th. So your whole numbers you multiply like normal. Your exponents both have a base of y, so you add them. So that's y to the 9th. Now, let's check your 3. There's a single whole number, check. There's no repeating variables, check. There's no negative exponents, check. So that is simplified. Don't make this harder than it is. Multiply your whole numbers, add your exponents if they're with the same base. Okay, next one. Let's look at B. If I look at B real quick, first thing I would do with this is what? If I had to guess. Actually, try it on your own real quick. Try it on your own real quick. Take about 2 minutes. Okay, we're multiplying. So you take care of your whole numbers first and then worry about your exponents. So worry about your whole numbers first and then worry about your exponents.
That's your responsibility this semester to figure out, bring your stuff you need, get a pencil before we do
You need that, yeah.
Someone have a pencil line, or not line, sorry, the shelf line.
We'll check just the 3 things work. Single whole number, no repeating variables, no negative exponents. Check here when you multiply -4 times -6. How are we doing over here? Getting it? Okay, now if you with your exponent. Take the same base. And what do you do with the exponents? If I'm multiplying with the same base, add them. No, not R7, because what's the exponent of the R? Nothing, because else 1. There's a 1 there. Yes. Okay, let's go ahead and look at this. So, part B, Michelle, you can just get it later. That's fine. You can go back and write them down later. Okay, so let's look at this. Do not overthink this. I know these are going to look complicated. I get it. Just do step by step. Take care of your whole numbers first. We are multiplying. So look at your whole numbers. What is negative 4 times negative 6? Positive 24. So you put it out front. All I'm doing is your whole numbers. We're not worrying about the exponents first. Negative 4 times negative 6 is positive 24. Okay, now let's look at my R. What is R? What is the exponent with this R right here? If there's not one there, it's R to the what? First. So this is R to the first. So if I'm multiplying, let's use that for now. If I'm multiplying with the same base, what do I do with my exponents? I add them. So this is going to be R to the, you look at my R's and you add the exponents. 6. Do not make this any more complicated than it needs to be. You multiply your big numbers, your whole numbers, and then you add your exponents with the same base. Okay? This is going to be x to the x squared. So that's going to be x to the 4th. That's going to be t to the 3rd times t to the 1st is going to be t to the 4th. Now check your 3. I have it down to a single whole number. I don't have any repeating variables. It goes rxt. I don't have more than once. Do I have any negative exponents? No. So that is simplified. Okay? Any questions on that so far? If there is, let me know, because I can help figure it out before we move on. Okay, a couple more examples. Power of a power. Let's think about it. Power of a power. We know what a power means. Power means exponent. So what does that mean if I have a power of a power? I don't see product in here anywhere. So what does a power of a power mean? How many exponents will I probably have? If I have x to the 2nd, I have that raised to a power, and then I have another power. So I'm going to have another what? Yeah, exponent on the outside. So let's say it's, I don't know, 6. So when I have a power of a power, that means I'm raising an exponent to another exponent. I have x squared to the 6th power. I have an exponent to another exponent. So let me go ahead and write it out. When raising a power to another power. So if I'm raising a power to another power, so when I have 2 exponents, so when I'm raising a power to another power, so when I have 2 exponents, all I do is multiply the exponents. So it's the opposite. Though when I'm multiplying, I add the exponents, like we just did. When I'm raising it to another exponent, when I have 2 exponents, I multiply the exponents. Okay. Any questions so far? So when I'm raising it to an exponent, I multiply the exponents. Okay, we're going to skip the next one. Let's look at example 3. I want to simplify each expression. You see the word simplify. So those 3 that we wrote up at the top, those 3 things apply. I have to have a single whole number. I cannot have any repeating variables, and I can't have negative exponents. So as I look here, what do I notice? Am I multiplying? Am I taking something times something? I'm multiplying in here, but if I look out here, what am I actually doing? I'm doing what? Kind of, but we're not really going to do that. What do I notice I'm doing here? I don't have two things multiplied together. I'm taking something to what? I'm taking this whole part in the middle, this whole term inside here, to the what? Third power. Okay? So, what we're going to do to simplify this is we're going to take everything to the third power. Kind of distributing, not really distributing, kind of the same idea. So we're going to take my whole number is going to be 2 to the third power. So the whole number you treat like normal. So it's going to be 2 to the third power. Okay, we'll deal with that in a second. What is 2 to the third power? 8. So we're going to put 8 right underneath that. So your whole number you raise to an exponent like you've done since middle school. 2 to the third power, 2 times 2 times 2 is 8. That's it. Now we deal with my exponents. So I look at each variable and I am raising that exponent to another exponent. So this is going to be y to the first. There's a 1 there. Even though it's not written, there's assumed to be a 1 there. So what do I do with my exponents if I'm raising them to another power? Multiply. So that's going to be y to the third. 1 times 3. F to the 12th. 4 times 3. I'm multiplying my exponents. And h to the 6. So it's kind of like distributing. It's not really distributing, but it's kind of the same idea. I multiply my exponents. Now, let's see if this is simplified. Single whole number, yes. Any repeating variables? We're good with that. Any negative exponents? No, so we're good. Okay, any questions so far? I know this stuff is complicated, but big picture, all we're doing is multiplying or adding, is what we're doing. Okay, let's look at part B. If I look at part B, I am raising it to a third power. So I'm raising it to a third power. So we're going to treat my whole number outside like normal. So I'm going to take negative 2 to the third power. It is not an exponent. It's a whole number. It's out front, so I just take it to the third power. So what is a negative 2 to the third power? Negative 8. Any negative to an odd power, odd exponent is always negative. So that's a negative 8. Now I look at my C. What do I do with my exponents? If I have an exponent to an exponent, I do what with them? Multiply. So that's going to be C to the 9th. Whole number is reduced, no repeating variables, no negative exponents. So that is simplified. So those are the 3 things you're checking for to make sure it's simplified. Okay, a couple more. Any questions so far? Okay. So let's go ahead and look at example 4b real quick. Express the area of a triangle with a height 4a and a base 5ab squared as a monomial. So let's go ahead and draw a picture real quick. So here's my triangle. We're going to draw 2 pictures. So let's just draw, this would be, it's been a while since I've done it. Isosceles maybe? I don't know. It's been a while since I've done triangles. I should know that. But which one has 2 sides that are the same? Isosceles, right? Yes, I think so. Okay? I have a height of 4a. So if I drew a triangle like this is not a right triangle. How do I draw my height? If I have a height of 4a, how do I draw my height? Dashed line down the middle. This is a little bit of review from geometry stuff. So this dashed line, this is going to be 4a. So this is one way you might see it written. This has a height of 4a, and if I have a base of 5ab squared, where's the base at? The bottom. 5ab squared. So I'm just drawing you pictures because on the homework they might give you pictures. That way you kind of know what triangle. So this is the same
thing, it's just representing 2 different things. Let's say I have a right triangle. Where would my height be if I have a right triangle? The side right there. Okay? So there's another way to represent, if I have a right triangle,
this would be, I have a height of 4a. And my base would be down here at the bottom, 5ab squared. Okay? Now let's think about this. I want to express the area of a triangle. What is the area formula for a triangle? What was that, Sean? 1/2 base times height. So we're going to start with the area formula, and we're going to plug in what they tell me. I want to represent the area. So I start with 1/2 base times height. What do they tell me the base is? 5ab squared. And what is the height? 4a. I want to express that as a monomial. So I want I want to simplify it. So I want a single whole number. I want no repeating variables. I don't want any negative exponents. So like we did. What I notice here is we're multiplying. So let's deal with my whole numbers. What are my 3 whole numbers here? 1/2, 5, and 4. So how do I deal with those? If I'm multiplying, how do I simplify it down to a single whole number? Multiply them. Okay? So don't worry about this half. What could I do with this half to simplify right at the bat? Instead of a half times 5, I could do a half times what? 4. What is a half times 4? Times the 5? 10. So multiplication you can do in any order you want to. So I did the 1/2 times the 4, which is 2, then multiply by the 5, I got 10. So your whole numbers you treat like normal. Now let's try to simplify my variables down. This is going to be a to the, what do I do with my exponents when I'm multiplying? Add them. So this is a to the, and if I look at the b's, this is b to the second. I don't have any other b to combine it with, so it's just b to the second. Single whole number, no negative exponents, no repeating variables. And that is your monomial. Okay. Any questions on that? Okay, let's look at example 5a real quick. A couple more, we'll be done. Now example 5a looks like a hot mess. Let's look at this. What do I notice? Let's think big picture. What do I notice happening here? What's kind of where's my separation point at? Like how many parts do I see if you look at this? 2. So I have this part right here. This is one part. And this is my other part. So sometimes it's helpful to kind of don't stress over it because it looks complicated. Look at your 2 parts. I have this term to the 3rd power and this term raised to multiple powers. There's a lot of stuff going on, but kind of separate it into 2 parts first and then kind of go from there. Okay, let's look at my first part and simplify from there. I have 1/2 a squared b squared to the 3rd. We're just dealing with this first part. This is exactly like we did last time, the couple examples ago. So let's deal with my 1/2. This is 1/2 to the 3rd power. My whole number is just to the 3rd power. You treat it like normal. So it's just 1/2 to the 3rd. Now, what is 1/2 to the 3rd? Don't stress out because it's a fraction. How do I deal with the fraction to an exponent? If you had to guess, how would you do it? Don't overthink this. If I had a fraction to the 3rd, how would I do this? Don't make it into a decimal. Take the top to a 3rd, take the bottom to a 3rd. What is 1 to a 3rd? What is 1 to the 3rd power?
1.
1. Over what is 2 to the 3rd power? 8. Okay? So 1/8. That's my whole number. 1/2 to the 3rd power is 1/8. Now let's look at my exponents. I have a squared b squared to the 3rd power. So how do I do a squared to the third power? What do I do with those exponents if it's an exponent to another exponent? What do I do with my exponents if it's an exponent to another exponent? Look back at your notes. We just talked about it. What do I do with my exponents if it's a power to another power? If it's an exponent to another exponent? So this is going to be a to the a squared to the third power, 6. B to the 6. Any questions? All I did was this first part. Any questions on how I simplified that? If you're zoning out because it's the first day back from the Christmas break, when you try this on the homework, it's not going to go super well. I need you paying attention, and I need you trying this, figuring it out. Okay, my second part here, we're going to deal with my inside part first. You always start with the inside part. So I have negative 4b, and that's all squared. So let's try this. What is negative 4 squared? Do your whole number. What is negative 4 squared? I heard it, Caleb. What was it? 16. And let's deal with my exponents. What is b to the first squared? If I have an exponent to another exponent, I do what with them? Multiply. So this is going to be b to the second. And that is all squared. Now, before I can simplify it all the way, what else do I still have to do on the second part? Okay, get rid of the squared. So my first part stays the same, 1/8 a squared b squared. My second part, I need to get rid of the exponent again. What is 16 squared? I don't know this. Someone do it on your calculator. 16 squared. What is it? I don't think so. I think it's higher than that. 16 squared. Someone do it. You have calculators out. What is it? What? 256. So 256, and it's going to be b to what power? Yep, multiply them. 2 times 2, b to the 4th. Now, these are more work. Is this simplified yet? We're taking a lot of notes today because we didn't go over homework. Is this simplified yet? We have 3 things to see if it was simplified. No. Why not? There's a couple reasons. It has a repeating. My b's repeat, so it's not simplified yet. What else do I notice that makes it not simplified? How many whole numbers do I have? The 1/8 and the 256. Okay? So let's simplify this. I'm multiplying, so let's multiply. My whole numbers. What is 1/8 times 256? Which is, how do I figure out 256 over 8? Okay, so what is 256 divided by 8? Is it 32? I don't know off the top of my head. Do it on a calculator. It sounds right, but try it real quick. 256 divided by 8. Someone do it. $256 divided by 8. If you have a calculator, do this, please. 32. Okay, now let's look at my exponents. I'm multiplying, so I'm going to have a to the what? 6. B to the? Nope. If I'm multiplying, these both have a base of b, so I do what with the exponents? I'm multiplying, so I do what with the exponents? Add. So b to the 10th. Now that is simplified. So some of these take a little bit of work to get it down to simplified form. Okay, I want to do one more with you real quick, because these are tricky. You'll be fine. You'll still have plenty of time for homework. I know it's a decent amount of notes for you. Okay, let's look at b real quick. Okay, do not get overwhelmed with these. It is very easy to look at this and say, I do not know where to start. This is overwhelming. I get it. I've been there. You have to start with the inside part and just start simplifying it. So let's look at my first. Okay, here's my two parts. Here's a part, and there's a part. Look at it as two parts, so we're going to simplify each part separately. This first part here on the left, what part am I going to have to deal with first before I do? Well, we're going to start with my inside part first. So we're going to deal with this 8g cubed h to the 4th squared. We're going to deal with that part first. So we're still going to have it all squared. We're not going to deal with the outside squared part yet. We're just going to deal with this inside part. So let's simplify this. What is 8 squared? Whole number. Treat it like normal. 8 squared. 64. Everyone go grab a calculator if you don't have one, because I want to make sure you can do squared on your calculator. So go grab one real quick, because I want you to be able to do it when we get to homework. Make someone get it for you if you're too lazy to get it. But have calculator out so you make sure you can do the squared part. Because we're going to get big numbers. Okay. Now, let's look at this. So as I simplify this, I have 8 squared, that's 64. Now, what do I do with my exponents if I am raising them to the second power? Okay. Homework is... I'll email you real quick. I'll email after class. Okay, so let's look at this. If I'm looking at my g to the 3rd squared, so what do I do with my exponents if I'm raising them to another power? So it's going to be g to the h to the 8th. When I'm raising them to another power, I multiply them. So that's the inside part simplified. Now let's simplify one more time. You're going to get big numbers, and that's okay. Don't freak out. Let's simplify it one more time. 64 squared. Make sure you can do this on your calculator. You can actually do it. 64, what is it?
4,096.
4,000, like that?
Yes.
Okay, so you can either do 64 times 64, or there's an exponent button, 64 squared, 4,096. Now, what do I do with my exponents? G to the, multiply them, 6 times 2, kind of like distributing, 12th, h to the 16th. That is my first part. That's only my first part. I still have to deal with my second part. That's my first part. I got it simplified. My second part, now what's going to be a little nicer about my second part? What's a little nicer about this second part here as opposed to this first part? It's only raised to what? 1 power. It's not to the 4th to the 4th. They're squared, squared. It's just raised to 1 power. So let's go ahead and simplify that. 2 to the 4th. So make sure you can do it on a calculator. 2 to the 4th power, or 2 times 2 times 2 times 2. Which is 16. If I'm raising exponents to another exponent, what do I do with my exponents? Multiply them. So g to the 4th, because there's a 1 here on the g. H to the 20th. I get these are overwhelming. There's lots of stuff going on. Just do step by step. Now, is this simplified? Remember those 3 things. Is this simplified? No, obviously, why not? There's more than one variable. G shows up twice, H shows up twice. There's also 2 whole numbers. Now, what operation is happening between these 2 parentheses? Multiplication. So do multiplication. On your calculator, what is 4,096 times 16? Whole numbers you treat like normal. What is
5,536.
Okay? I multiply my whole numbers like normal. We don't worry, we don't stress out unless they're exponents. We have to do something different. Whole numbers you multiply like normal. Exponents, I do what? If I am multiplying, I do what with my exponents? So this is going to be g to the 12th, 4th. 16th, h to the, they have to have the same base. 16 plus 20, 36. And now let's simplify. So I get, you might get big numbers, there might be lots of stuff going on, just do it step by step. Okay, you guys can do this, I promise. If not, then you can ask one of us and we can help you. Okay, homework. What did I do with my book? Okay, 7-1. It is going to look like homework will be page 394. One through 20, 39 and 40. Now it's a little more than normal, but the first 6 are like, don't take any work at all. You have to just say whether it's a monomial or not. So 1 through 20, 39 and 40. That's your homework, 394. Okay? Now like I said, I am fine, and I said this first semester, I'm fine with giving you a lot of time for homework in class because I don't want you to have a ton of homework. Now it's annoying when you don't use it, and then you don't turn homework in, and we start the whole process over.